Wonderful. Thanks so much. So with that little hiccup out of the way, hello everyone. Great to be here again, and thank you, Peter, for the introduction. And yeah, it's great to be back again and talk about another talk. And yeah, pretty much Peter gave a brief introduction, but I'm going to introduce the topic as well. So I'm going to be talking about Produktify, which is basically more or less a story of how I built a serverless calendar productivity app. And this all essentially was stemmed from a problem essentially that was originally brought up particularly from educators because in particular, educators always face a particular issue of alternating schedules in a way. And I'll be going into that more as we go along this, and it'll make more sense as well along the way too. So a bit on myself before we start out. So again, Renaldi, I'm currently a software engineer at Seek. And I currently hold all 30 certifications for AWS. I'm a SME as well for the AWS Solutions Architect Professional and AWS Data Analysis Specialty Certification. I'm also an organizer as well for the Melbourne Python user group. I am currently also have spoken as well at more than 30 conferences and events. And yeah, particularly in general, just love to chat about all things AWS, open source, and VR. And recently have been actually going a lot into the Gen AI space with doing a lot of research as well into Bedrock and a lot of, in general, like applications regarding Gen AI. So that is just a brief overview about myself. And what are we looking for the agenda for today? And also, just a quick disclaimer as well. If you see any of these images as well, they are pretty much this is basically my first presentation that I am actually experimenting with using DALL-E 3 images on, because I am actually curious. I'm actually astounded by how good they're actually able to do images. So I'm basically just like going to be putting this all over the place, basically, just around the place as well, basically. But yeah, so pretty much the agenda basically for today is going to be more or less going a bit about the motivation of why we need such an app, and I'll be explaining that along the way too. And I'll be talking about like the planning that I did, how I eventually got to this point, how I started implementing things, the architecture, which is where we're going to get into the nitty-gritty things of the technical side of things. And afterwards, going to talk about how iterative development is needed, especially as part of this, how we can continue building onto that. And finally, future developments, what I plan to do, and essentially what I see as well the future of developing such apps as well for educators as well. So what is the motivation? Firstly, as I was mentioning before, it's really in general for the changing schedules for educators. So the way a lot of educators have it is, if you're not too familiar with the ed tech field much, or in general with the education field much, educators, teachers in particular, have this interesting schedule of kind of like alternating schedules. What I mean by alternating schedules is, for example, say they could have a schedule for a class for 1 week, for example, that actually moves like this way, but on the next week, that could actually have an alternate schedule. And that's what I mean by alternating schedules. It's a bit difficult for traditional calendars, such as like Google's like calendar, for example, to like actually like alternate well or take into place account well. And basically, because of that, that leaves that particular like sweet spot essentially to try to create something for that. And aside from that, in general, it's good to be able to keep track as well of productivity as well on one platform, which is what I try to do as well. I try to particularly create more or less kind of like not only calendar-wise as well, but actually try to throw in different stuff as well into the website as well. Might as well help kind of like educators like, keep things in one platform too. And more or less just encourage more open source as well within the edutech field, because in general, I feel like ed tech in general has not really been a key focus of developments within the open source community. And so particularly projects like these are aimed towards being able to try to motivate more development as well within this field, try to actually find a bit more, and actually try to create more feasible solutions that can help our fellow educators as well. So what did the planning look like for this particular case scenario? Well, first, it's consideration, of course, that educators might have multiple schedules. In one case, for example, an educator might have one schedule for basically 1 week. And like I mentioned before, another scheduled for week 2. So these kinds of things is the thing that requires consideration. And aside from that, it's also in general, being to keep track of to-dos and documents are a very important thing. And we'll get into that as well as I go about talking about the implementation too. And afterwards, it's also more or less understanding the data structure as well if the data is needed. So more or less understanding how you'll save the data in a database. And in this particular case scenario, we're going to be looking at using DynamoDB for data storage. And in general, pretty much talking about why we're particularly choosing DynamoDB, or we're particularly choosing like RDS. And yeah, basically just more or less understanding that and trying to accommodate accordingly. Aside from that, it's pretty much also considering how we can essentially create friendly user design. Now, I'm pretty sure like most of us, if not all of us here, are somewhat quite familiar as well with the AWS platform. We know a bit about, how can we debug different problems, but our fellow educators might not be as informed basically as we are regarding how to debug such platforms. So that's why we need to consider how we're able to essentially accommodate for that. And aside from that, it's a process of continually getting feedback. Like, how is this being integrated for educators? How are we basically doing this properly? Are we doing this properly? So it's all basically about that. So what does the architecture look like? And just a quick note, please ignore the RDS logo. That is supposed to be DynamoDB. I'm not sure why that's RDS. But essentially, this is more or less how it's supposed to look like. This is more or less how the flow goes. We have the 3 main components of the authentication on the front end, more or less, that's being done, the back end, and also the database layer that is currently being here. So we can see over here that in this case scenario, we're particularly using Amplify to be able to handle most of the authentication. And after that, pretty much we source our website out of S3. So it's basically hosted as a static website. We basically just put it in S3. And particularly, Amplify handles the authentication necessities. And Amplify pretty much, helps to authenticate and save your credentials as you register and sign in. You cross-check with Cognito. And after that, that is fed into the API gateway, basically, which then essentially is where we go into the back end. We start to send requests from our website to API gateway as requests, which then is redirected to AWS Lambda, which in turn sends the requests accordingly and processes it from the back end. So what does Lambda do on the back end? Well, it connects to 2 different sources. First, it's Secrets Manager. And why do we Secrets Manager? Because we're particularly using it in this case scenario to be able to source off the secrets we actually currently store. And in my case scenario, it is basically used for stuff such as the such as like the database key, for example. And because that was previously originally based on to as well, and which I'm going to be talking in this slide too. So as mentioned before, in terms of security, the things that were considered in this particular case scenario is usage of DataBlade tokens to be able to authenticate requests as well from every front end too, to ensure that you're actually who you claim to be as well, based on your unique DataBlade token that's created based on your session. And we have secrets managers as well to rotate the access of API keys. And in general, just to be able to also ensure that encryption of data as well is basically being adhered to as well throughout the whole thing. Some considerations that are also important when doing these kind of things is basically considering the balance of latency and costs. So in this particular case scenario, since this is a test environment, it's certainly not too big of a deal to actually run, for example, say, on Lambda with actually kind of the minimal requirements particularly, and with DynamoDB as well. But it certainly will become more of a problem as well when users use it too. So this is definitely something that I've taken into consideration over time. And that's why I've experimented as well with different approaches, for example, say RDS. And originally this was based on RDS because the data was more structured, I thought. But over time, I decided that, you know what, Lambda, I feel, pretty much actually is able to cater for this more. And because my data is able to be pretty much like fetched by a Lambda and DynamoDB too, and well, it's cheaper. I think I pretty much like probably like save like 3 times the deployment cost per day, honestly. Just let Lambda, let that be a serverless pitch. And in general, just consider as well the data structuring as well that is needed to be able to how you choose to partition your data, how you choose to pretty much like more or less like navigate with that. So now comes the fun part. Let's take a look at a bit of the demo, and hopefully Windows does not jeopardize me again. Let's see how that goes. And well, it has jeopardized me again, unfortunately. But let me see if I quit the slideshow, if that actually makes things better. Let's see now if I move here. Oh, beautiful. All right. So yeah, we can do that. And so basically, this is a brief look at pretty much the open source calendar app that pretty much like I created. So briefly, it's, as I mentioned before, it pretty much has the functionality of a normal calendar. So yeah, you can create stuff basically. You can more or less like, now go to week. You can pretty much drag stuff. You can more or less, just like put like random events as well. You can choose the color accordingly too. But what the main component that is essentially what I'm trying to solve here, remember, is the potential for alternating schedules. And that particularly is what I solved as well by this particular feature, which is basically the potential for it to alternate schedules accordingly. And as you can see here, after I click configure schedule, so these are essentially the schedules that I wanted it to be able to take in. And basically, you can basically kind of like put like different schedules. You can add another schedule. But basically, the whole point of this is so that whenever you switch schedules, basically, you won't lose stuff. You'll keep being able to alternate accordingly. You can choose a start date, end date. That's essentially what I wanted it to do. I wanted it to continue alternating based on these particular schedules. And as you can see, for example, like I have like one, for example, like for AWS certification exam prep. And basically what I want to do is more or less to alternate with the other event, for example. And more or less what it'll do is then it starts to do it every other week. And it'll stop at the date that I particularly put here as the end date. So this is particularly just an example as well of like how I particularly developed this solution as one particular solution to solve this particular problem that educators are having. So with that, now let us go back to the presentation. All right, and so what are some future developments that I am thinking and that I feel like would be good as well for the community to look into? AI support agenda planning. As I was mentioning, this is something I'm looking into. I am already a bit into it, but it's still something that I haven't fully developed yet. There's still bugs, so it's not presentable yet. So it's something I'm currently still continuing and trying to do. Also, particularly stuff like rating to be supported by AI too. I know there's a lot of debate right now on the ethics of AI and all that. Pretty much, I choose to be more on the optimistic side personally. But and aside from that, there are also like the potential for sharing calendar availabilities too. Or of course, with all of that, there comes the need as well for more testing to be done. And pretty much just considering as well when it's pretty much like brought to a bigger audience too, maybe it's good to consider this deployment as well on CloudFront distribution and Root Review 3 as well when it goes to production environment too. So what are the key takeaways? There's the evolution of educators' needs that come along with today's educational methodologies, essentially. There's always the need for better ways of doing education. And essentially, one of the things that can make educators work easier is through the development of these such open source solutions. And creating a unified solution essentially is a very important thing. And that's basically as well like why I'm making this more or less like call to action as well, to kind of like more developments within the open source community for educational technology too. And just in general, consider stuff like scaling with serverless architecture, which is a very important thing to consider as well as you develop more too over time. And consider as well more robust front-end development that is needed too as part of the React considerations. If, for example, if you're playing with React or PHP or anything, all of them is particularly necessary. And in general, just be able to also hopefully handle seamless documents better as well, seamlessly as well that way too. So with that, I would like to conclude my talk. And yeah, particularly if you would are interested in checking out the current public testing environment I currently have, you can actually go here. I know it's a mouthful, but can we put the slides up on Meetup maybe, like something like that? Yeah. Okay. Yeah, I'll put the slides up on Meetup, and yeah, people can take a look at the slides as well. So these are easily accessible too. And yeah, if you'd like to ask any questions now or connect with me and ask questions later, that's fine too. But yeah, in the meanwhile, I'll hand it back to Matt.
Any questions?
Yep.
Did you consider using like document text extraction in terms of like Lambda from the cloud rather than from using text extraction? Like the AI text extraction from cloud?
Not so much. I have I particularly use TextRack in this case scenario because I have been mostly playing around with TextRack, yeah, pretty much within Amazon as far as I know. But so far from my experience, TextRack has been able to do a great job at text extraction. So that's why I've particularly been using it. Yeah.
Two questions.
Yep.
First question is since you had a slide on balancing latency and cost, do all the costs of AWS become into DynamoDB converted data?
So,
Can you repeat the question?
oh, sure. So I believe you asked that if
all the cost of the serverless calendar settings come on, does it all the components of the AWS that it used, like Lambda, Cognito?
Yep. So you're asking basically if all the costs are actually part of the free tier. That's that correct? Yep. So I'm not exactly across, I feel like, what service are in free tier in my head.
Yeah, it's just usage, right? So if you start dumping it, it's gonna
Out of my knowledge, I think those services are definitely in free tier, but just to a certain extent. Unfortunately, I can't comment on. I feel like the right numbers on that. I'm maybe like some but yeah, that's definitely what they're definitely a portion of it that's like free tier. Yeah.
Second question I had was you mentioned about extract for handling documents.
Yep.
Did you use a Lambda job for it, a library and a Lambda job?
I feel like you could. I particularly used TextRack out of convenience in this particular case scenario because TextRack is just basically a insert text, connect to API solution, and you don't actually have to like create too much of a Lambda, in my opinion. And some people might disagree on this, but I feel like Lambda is a bit of a overhead. I think too much like overhead in this particular case scenario. So I particularly just decided because it's a bit easier, and I feel like the costs don't actually amount to much. It definitely is a good solution, yeah. But I might think otherwise, pretty much like as users grow, particularly. Peter?
What's your plan for the product? Are you keeping it open source? Will you commercialize it at some point?
Right now, my plan is pretty much just open sourcing it right now. So no further plans from that. Yeah, I'm just inviting more development to be done in this area. Yes.
Have you think about the notification, sending the notification for something in the schedule, maybe?
Notifications, you say?
Yes.
Sorry, could you repeat your question on?
Have you think about how is your architecture flexible to send a notification to the user?
Okay, I see. In regards to your question about sending notifications to the user, I believe that it's certainly an avenue that I have thought about. I haven't really implemented it yet, but I definitely do think that there's a potential for basically kind of like doing something like Google Calendar does, for example. Like when you have an event coming up, you basically kind of like send it over. I did already have like the thought of like converting this into like a mobile app as well. At some point too, to be able to like make it easier as well for user to reach notifications too. So definitely on that end, that's a yes. But yeah, it's just basically not implemented yet. Yeah. Yes.
Do you consider to add any sort of monitoring or alerts to your Lambda services, and if so,
That's a good question. So if I'm not understanding correctly, you're asking if I'm considering adding kind of like monitoring to my Lambdas in terms of, for example, usage, you'd say, maybe?
number of errors because you mentioned broadly, you mentioned usage and all of these things, let's say. Because I find it maybe to try to monitor the Lambda has all of these methods combined or clubbed in one function. But how do you plan to monitor what exactly if there is a bug?
That's a great question. I feel that for now, monitoring more or less I feel like it's going to be a bigger priority. I feel like as this app like scales along. So it's not exactly the biggest priority right now, but I feel like my outlook on it pretty much is really in general is more or less kind of like try to lock things a bit as well and try to like monitor the overall usage, I'd say, in terms of I'm planning more or less how I see it is I'm planning to like flesh it out more in terms of the endpoints, like how it particularly asks the endpoints in terms of like the CRUD requests based on the Lambda function. And as it scales along, I might also split the Lambda as well, particularly to be able to have the requests like being able to be taken by multiple Lambdas and basically scale better with that way too. But yeah, that's like my outlook on that at the moment. Yeah, hope that answers the question. Yes?
Yes, is the project open to public contributions?
Yes, I haven't put it to open to full contributions yet, but I'm planning to put it on open to full contributions as well. Yes. Yep.
You talked about document management.
Yes.
Did I miss something? Like, at what point were you doing document?
Oh, sorry. I have to clarify. So document management is basically referring to the text track segment. So basically, what I was referring to that is essentially regarding managing documents on the cloud when you actually upload them in terms of the images, basically. Sorry, not either images or PDFs, basically, and you can basically store them on the cloud that way instead of like, for example, from an image or an unreadable PDF, basically. That was like what I was referring to by documentations.
So how does the calendar relate to the documents?
As I was mentioning before as well, the plan of this is the calendar is main thing, but what I plan to do eventually is try to bring more things that educators need as well as kind of like a part of the education, as part of kind of like a suite as well. So let me show like one of.
So you want to store documents with the calendar then?
In a way, yes, that's correct. So the calendar is still the main thing, but it's certainly one of the things that is, as I mentioned before, it's basically more or less kind of like, in a way, a suite of tools as well. So instead of like just a calendar, it's basically to also like contain other miscellaneous stuff that might be necessary as well. Like for example, like I actually forgot to like mention this as well. But for example, like a to-dos, for example, is also created here as well, basically just to keep track more or less of like what educator like just like a simple to-do list basically of like what educators are so that they can keep track of things as well. So yes, basically.
So are they stored against the events in the calendar or is it just separate?
It's a separate thing at the moment, but
Separate thing.
Yes, yeah.
Because it would be good if you could store it with the events in the calendar, right?
Yes, I agree. It's
Yeah,
it's
you say these things on, so here the lesson notes.
Yeah, I think what you're referring to is attachments.
It should be either way.
yeah. I think it's what you're referring to as attachments. That's correct. Yeah, but it would be a good point of development, I think. But yeah, it's just hasn't been covered yet in particular in this case scenario.
If you could, yeah, just a question. I mean, we're having conversations about what might be good or not. In terms of feature triage and discussions around what's good for the product or not, how are you going to manage that?
I feel like more or less when this does go pretty much like open source, it's pretty much just going to be based on. I feel like, yeah, just like a priority list. I feel like in seeing like, I think it's a lot of like need finding to do as well, like considerations as well. So the whole process I haven't thought of much yet, but I'd like it to be at least kind of like a discussion, I feel, more or less to be had. So yeah. Cool.
Thanks, Renaldi. We have Saad.
Okie dokie. Thanks, Ron. Let's see if this works. So what we're going to look at. So hopefully today you're going to walk away with a bit of understanding of how you can use serverless, or Lambda in this case, inside of an enterprise. So you get to understand a bit of a novel business problem. You'll get a brief understanding of how you go about selecting architectures for your solution, and some inputs that are distinct to enterprises that you might not necessarily see at other organizations. So you'll see some code level stuff, some throwbacks to the previous talk you actually saw, which is what I was laughing before, and some considerations around the deployment and the operations of it. Okay, so who's me? It's a lovely picture of myself, looking happy. I've been around for a long time, been working in the industry for about 15 years across a bunch of different brands. Yeah, mostly in the infrastructure space, not so much on the programming side. So more infrastructure, not code. So my code's not great. So what was the business problem that we led to this unusual situation? So rightly or wrongly, the business had decided to, another business unit had decided to go out and purchase a replacement SaaS solution. And that SaaS solution was actually not really a SaaS solution. It was a pseudo SaaS solution, as I call it. It was some physical appliances that ran in its isolated network that had a internet ingress point, and that was it. So it was a security product. Some stuff came in from the internet, and then it did some things and some stuff out the back of it. The business had already budgeted that they're going to save the $3 million that year. So it's, a bit of panic. They had about 14 days left to deliver it. And yeah, so it wasn't happy days. So with the $3 million, it was actually a license renewal was coming up. So they ideally didn't want to pay for that license, right? So I'm not sure how this actually came to me, but someone asked me about it. The RPA team, the robotics process automation team, had said it's actually not possible. They couldn't do it with 14 days left, whilst they're trying to save all this money. And they claimed that was due to a CSRF token, which wasn't true, but that's what they thought was the issue. So yeah, the ultimate solution that we needed was to get it from this lovely little island on the internet down into the Splunk environment over here. Now the issue with this was that the two transport modes that was offered by the solution were syslog and HTTP, which we'll talk about on the next slide. Similarly with enterprise solutions, you don't really have the option of going straight to the internet. So let's say we're hosted here in the workload account. We can't go straight out to the internet through round-to internet access. We'll have to go out via a common service layer, whether it's a router or in this case, it's a split proxy. And we're obviously not going to send syslog over the internet because it's unencrypted, and UDP, which is means malleable. If you go to TCP route, it's even worse because you've got the DOS concern. So how do we go about thinking about how we're going to design the solution? So if you're not familiar with this concept on the right here, this is called Conway's Law. So an organization builds software solutions that it reflects its organizational structure. This is something I really think about. It's actually my last point, but when I'm thinking about designing solutions, I think about who's going to own it at the end. So it's really important to think about like what skills they have, how they interact with other teams, and those sorts of things. So the first thing I did was request access solution to confirm what they're saying. So after getting access to it, I had a poke around, had a look at like how it worked, what it looked like, confirmed that yes, it is only syslog and HTTP download. The next step I took was, whilst poking around, was to actually simulate downloading the files whilst observing through developer tools. So I could observe the HTTP requests, see the headers, see the the URIs, and see how that CSRF token that I was talking about was working. So it turned out it wasn't really a CSRF token. It was actually a session token that was baked into the get URI. A small detail, but it was a bit miffed by that. So after I'd explored and figured out a plan of how this actually worked, I then used curl to test these individual endpoints, and basically just document the notepad, right? So use this command, does this, logs in. This command then goes and browses the page and lists out the log files. Then the next command downloads those log files. So after I'd looked at those curl commands and written those down, tested a few times, pretty comfortable with it, went back to the business, said, hey, I think it's going to take about 48 hours. Felt pretty comfortable with that. And they said, we'll give you 7 days to get into production, which was, pretty comfortable for me. Obviously in enterprise, you got the change control component and the, all the documentation has to go along with that. So it's, it's a bit more on top of just the development process. One benefit was with each of these log files is that they're uniquely named. So they had a hash in the name once they're rotated. So the current file was, mail log, and the subsequent was like mail log dot, XXX, and then YYY, etc. Which comes important later. And again, with these sorts of solutions, you have those normal enterprise concerns. Like, you don't ever want to lose these logs. They are security logs. They are important to the organization. So you never want to design a solution that could drop these logs. It's okay to have too many. So if you accidentally duplicate logs, not so bad. But if you lose them, that's really bad. In terms of scalability, what I was seeing, back in Napkin, my calculations were it was going to be in the hundreds of megabytes per day. And then, per an hour. But when I was actually doing my tests, I was actually finding it was tens of megabytes per an hour. I was a bit suspicious of that, but it is what it is. That's what happens sometimes. And as I said, I really wasn't sure who's going to own it, which was a big problem, right? So when I was designing it, I had to think about it could go to this team, it could go to that team, try to make it as team or technology agnostic as possible. So this is the solution in architecture, if you can call that I landed on. It's quite basic. So over here, you can see that we've got the clients out on the internet. We've got the first Lambda job, which is a download from a device, extract it, and make it do a bit of transformation. System state over in top of Dynamo. We'll then push the logs into CloudWatch logs. And then in the CloudWatch logs, you can actually have like a pub sub model, like the subscriber. So it's not SNS, but it is a pub sub model where there's CloudWatch events, which basically monitors these events. They go into logs, and then that will trigger another Lambda job. This Lambda job will be responsible for sending over to Splunk on the HTTP port in Splunk. So HEC is a HTTP endpoint collector, I think it is, for Splunk, which is a HTTP endpoint for collecting logs. So I came up with this pretty quickly. Like, this is one of the first ideas I had. And then my pretty standard process for validating my idea is actually good is to do an options analysis. So I'll think of like 2 to 3 other ideas which I think could be better, and make sure that this idea is actually good. So one of the other ideas I came up with pretty quickly was running this on Azure. So as you may notice, this is a collection of AWS suite services, but we also had a pretty hefty presence on Azure as well. So I thought about, which clouds are better on. There's a few reasons why I went down this path. One is that Splunk happened to be hosted in AWS, so you're going to have less data transfer issues. But more to the point was that at the time in that organization, they required the Azure functions to run inside of an ASE v2, which is application service environment, which is basically a fixed piece of infrastructure that costs you around $1,300 a month. So why pay more? This is basically free. A few other alternatives, so you might consider using like SQS, because it is a very natural thing to think about with a queue. I think it's a good idea. The issue with that is I'm really concerned about replayability. So one thing that can often happen is that your Splunk collectors are down. You wouldn't expect it to happen, like normally they're extremely highly available, but they can be down. So in the event that you need to replay, if it's in a queue, that can be a problem. Obviously, you can do some things about that, but if it's down for a long period of time, then your queue might expire. The other idea I had was around non-repudiation. So security logs, you often want to be very sure that what you captured is accurate. So if that be you go to portal or anything like that, you've got these logs here stored raw. If it's in a queue, you can't tell that because it's gone, right? So it's ephemeral. The other thing I would have looked at was running it on VMs or containers, as I was having that conversation before. The challenge with that I thought about was that I don't know who's going to operate this, so I need it to be as low touch as possible. So that was why I ruled that out pretty quick. Yeah, and as I said, like the reasons I chose it was we got this at least 30 days of these logs, and if they needed to keep it for longer, they could tune up the CloudWatch logs to store the logs for longer than 30 days or whatever, what time period they wanted. Okie dokie. So as I sort of hinted at earlier, the network flow is not as simple as you would expect in most organizations. In most organizations, you're pretty comfortable just sending out straight to the internet. In most enterprise environments, you're really concerned about controlling the ingress, so the data coming toward you, and the egress, data going out from the organization. So with the view that you're stopping people from stealing your data and selling on the dark web. So in this solution, there's a lot of little numbers down here, which might be hard to see, but we have attached ENIs to the Lambdas, which controls egress traffic for the Lambda. So that's going to say when you try to connect to anything, go by your VPC inside of your account. So we've got the 2 Lambda jobs. So if we look at job 1, which job 1 was to get the events out of the device. So that connects out via the CPU, customer premises equipment. So in this solution, in this organization, it's all kept by on-prem between these AWS accounts. So it goes down via the CPU, then back up to where the SQUID proxy is running, out by that, the IGW, and eventually lands in the island and grabs the logs, pulls that down over HTTP, updates its state about, hey, gotta process this file a little bit, and then sends the logs into CloudWatch logs. That then triggers that event. And that event is notifies this Lambda job over here. Not quite like that, it's just an object. And then that guy looks at the state, looks at the log that's coming into the event, and then ships that out over HTTP to HTTPS to Splunk on its HEC collector port over here. So if you're not familiar with Splunk, it runs multiple layers, but the collector layer is just VMs that are listening on port. I'm pretty sure it's TG8080. So the good news here is you've got a fixed or set of IPs at least coming out of your SQUID proxy. So on the island side, you can say trust these IPs here, and from the workload side, you're going via the trusted route. Forgot to mention the SQUID proxy does use hostname-based whitelisting, so you can only go to certain hosts, right? You can't go to anywhere on the internet. You can only go to these known hosts. So obviously, work had to be done to implement that in the whitelist, of course. So, pop quiz. What does everyone think is the hardest problems in computer science or software? Any call-outs? Caching. Any others?
Naming.
Hey. Anyone got the holy trifecta? Hey, thanks, Peter. So you're close. Any other call-outs? 2 or 3? No. Off by 1. Yeah, time math. Time math is absolutely the hardest thing in software development, hands down. Don't believe you if you say anything else. Obviously, don't write your own crypto, don't go to speed trees, blah blah blah. Yeah. So in this solution, the appliances actually store stuff in local time, and those devices were configured for Melbourne. So you start thinking about scenarios like DST. Yeah, so it's suddenly a fun thing. So if you're not familiar, Lambda uses UTC as its time zone. So when you're writing software, you need to be really cognizant of which time zone things are using. It gets even worse than this. You'll see in a few slides. Next slide, actually. So this is an example of some of these timestamps. They're actually not real ones, but pretend they're real ones, of timestamps coming from the devices. So anyone familiar with parsing time streams? You can see some problems with this, maybe? No call-outs? So the first problem is there's no year. Second problem is there's no TZ, so time zone. There's some unusual problems around spacing, some non-standard characters. So this was like the whole collection of bad things you want to see when you're passing time. So when I was writing the code for this, it involves some pretty, pretty nasty. This is pseudocode, obviously it's not real. pretty nasty extractions, so some regex extractions, and then essentially a minus, because when you use a timestamp, it thinks it's in using 0, but the time is actually in ahead of that, so you have to minus the time zone offset. So in this case, I used the environment variables to contain the UTC offset rather than trying to do this in code, because I had a very short time window as I started the talk with, which brings up some problems later down the line when you start hitting into April or October. I did update this in the code later, but yeah, that was the sort of initial issues with that. So in terms of overall code, we used a lot of Terraform for the deployment. Again, I didn't know who was going to be operating this, so I tried to keep it as basic as possible. The app code was just the 2 Python lambdas, so it was very simple. So that first job, which I took down the top there, is a timer job. So that was responsible for essentially extracting the events from the device. So, look at its state. It would compare the state with what it saw on the device. It would then determine whether it needed to download those files. It would go look at the files, determine if it needs to download the files, and then it would extract that text and then push it over into CloudWatch logs. So if you're familiar at all with using the AWS APIs, you would use the Bodo libs. At this time, it was Bodo 3 was out and the most popular. Obviously, before that was Bodo 2. And that was, I used that for talking to CloudWatch logs and Dynamo. Then on the other side, we've got the transformation job. So as I mentioned, the time math is the worst thing in the world. It's definitely the hardest. You won't convince me otherwise. We used Python requests, as we used in the other job, to write the HTTP request to Splunk. So there's obviously some formatting there, and there's a bunch of considerations around the structure. So if you're not familiar with the Splunk heck, there's 2 modes that you can send events. One is as a serial mode, so you send one event at a time, wait for the HTTP response, and another event, or the batch mode. The batch mode supports up to 1 megabyte, and you just list events like delimited, delimited in an array, I think it is. Now, if you go down the first path, you run into issues with performance because I believe it's ACID compliant, but at least it waits until the data is committed down to the storage nodes before it sends the HTTP response back. Don't quote me on being ACID compliant, it might or may not be. So yeah, you definitely want to use the batch when you're doing large amounts of events like this, where you've got tens of megabytes of, at least megabytes of events per file, right? In terms of the Dynamo state, I sort of, why did I use Dynamo? Well, again, I didn't know who's going to be operating it. It's cheaper than RDS, as we talked about just before. It's quite very structured information. Well, the schema wasn't changed, so it's not necessarily a good choice. It is very structured information, so didn't choose it for its features. I chose it for its cost and its maintainability. You don't have to do anything, right? An RDS, you're going to have to wait for, there's going to be version upgrades down the line, and yeah. There's also a small remediation script. So as I mentioned, there's a risk that sometimes the heck will be down and it'll try to ship events. So a little bit of a monitoring job that would see errors and it would spit out notifications for someone to go fetch it. Who? I don't know, because don't know who's going to own it. To go and run a script which would pick up the events that were missed and then resend them. As you can see, I went with a pretty dumb approach to TZ math. There are probably better libraries out there, but when you're coming to pushing code into Lambda, you may have experienced that sometimes getting a library, especially if it's a non-standard library in there, can be a problem. Probably would have been better ways to do that. There are libraries like TZ-info and TZ something else that do jobs, but when I experimented with them, they didn't work out of the box. I went with something, given my very short timelines, to go with something that I knew would work reliably, and I knew exactly how it worked. So, oh shit. I'm about day 2. I was feeling pretty happy with myself. Like, hey, I've rigged on it. It's all working. I just called up the Splunk, the guy that's on the Splunk side of things, and said, hey, it's all done. So he's doing his thing around creating reports around the security events. And a couple hours later, he gives me a call back. He's like, I can see events for one device. I'm like, uh-oh. Yeah, so it turns out that the portal I was using is the sort of master portal, which represents the master node. It turns out there's actually a portal for each device, which was good in this case because I mean I could go address each device individually and get logs out of each device. So what I failed to mention to you is there's actually 14 devices in total for this solution. And if you remember back, I said they were expecting 100 megabytes per an hour. Well, you know, divide 1 by 14 and 14 by 1, and yeah, suddenly your 10 is, you know, should be 100, you know, mid hundreds, right? So yeah, it turns out my initial back envelope calculation about the size was correct. It's just I was only getting one device's log. So how to go about fixing this? Well, I went with the easiest and the dumbest way possible. It was basically just to fan out the jobs. I'd actually probably pick this method again if you gave me the option. It's probably the right decision, and it associates essentially one timer to one Lambda job to one CloudWatch job, queue, all the way through, right? So in the event that there's an issue with one device or one device is updated and it starts having issues with this solution, you can pretty rapidly, isolate that one and just leave it there, and your other 13 are going to continue to work. Like quarantine is the word I was looking for there. Yeah, so worked good. It only took me a couple of hours to come up, to deploy that with Terraform because you just copy and pasting 14 times. Did I make an error? Yeah, I did. But I fixed it pretty quickly, and happy days. Within a couple of more hours, within my 48 hours that I've allocated, it was done. Customers happy, well, internal customers happy. So yeah, happy days. Operations. So as I mentioned, use Terraform code to do deployments. It's pretty simple code. There's like 5 files or so. The one big issue was I was storing Terraform state in the GitHub repository. It's definitely not something you should be doing. But again, coming back to I don't know who's going to own this. I don't even know what AWS account's going to live in, so it's going to have to move accounts at some point. I figured that was the best location until that was decided. Yeah, normally you should be using S3 as a backend or Terraform Cloud if you swing that way. However, I did get it was actually this year. I don't know. So obviously there's some documentation, some handover. Eventually we found someone to own it, and they sort of didn't know what was happening. It was like, does it run? Yep. What errors am I going to have? None. Okay, we'll own it, I guess. And then then April I had to do the time zone change, and then I fixed the code, and then I didn't hear about until last year. Someone called me up, it's like, hey, this solution you built, does anyone know anything about it? I'm like, yeah, maybe. Yeah, so I just gave some pointers, and I think it was just a Python version that needed updating, and yeah, it's happy days after that. So haven't heard anything since, but yeah. So obviously fairly reliable. So what we find, Lambda, serverless in enterprise, I don't think it's anything surprising. I think it's, it certainly has its place. Maybe it's not the microservice nirvana that's being sold and everyone talks about, but it's certainly allowed in this case, definitely, us to go from zero, like no solution, we're going to have to pay another $3 million this year, to a solution in production, operating, fully documented it within a few days. Obviously, I had some issues, but again, we were able to demonstrate that we're able to rapidly iterate. Was able to scale, obviously, a full order of magnitude, which is something you can't really do in traditional infrastructure anyway. And basically, for 3 years, it ran without issue. Someone probably should have rotated the token, the hex token, in that time, but I don't know. Maybe someone did, and it worked. I don't know. Time math definitely sucks. I don't recommend it. Stay away from it. Ask Renaldi. I don't want to know about it. Cost was really cheap for this solution. I think it was, again, don't quote me on this one, but I think it was about $150 for the whole solution per month. So dirt cheap. So yeah, that's how we saved a large amount of money with minimal amount of work, with minimal amount of infrastructure, novel solution, very short period of time. And could you have done this without serverless? Maybe, but definitely help being on serverless, I think, in this case. And that's the last slide because I don't have a thank you slide, but thank you for your time.
Questions?
I do have a question for that. So you are listening to CloudWatch logs from CloudWatch events, and then you're pushing CloudWatch events to Splunk using a Lambda job. And once they're done, you're kind of letting this offset know that for this timestamp, the logs are persisted in Splunk. That's what the update state is. Yes, so basically that's the only thing I have. CW is
So there's probably a couple of things in that. Like, so Splunk does have the ability to, when you send the message on the heck listener, you can tell it what timestamp to index at. So there's a receive time and an index time.
So you're duplicating your logs in CloudWatch logs as well as Splunk.
Correct. So the logs are duplicating in CloudWatch logs, yeah. And that's, as I started with, is by design for the non-repudiation aspect. So normally these are expiring within 30 days by default, but if they do need to be retained, so let's say there's an event where someone's really suspicious that something happened, legal or security company, like the CERT team will come to you and say, hey, can you persist logs? And then you'll increase the log retention or otherwise export them non-repudiated to another system. So another issue was these devices here had a log window of 24 hours and they couldn't reconfigure that. So
have you considered streaming?
As in Kinesis?
It seems like it's an extract transform load, but have you tried streaming the logs from appliances? Like just push the logs in a message broker and consume it to Splunk.
Yeah. So
Kinesis, yeah.
Yeah. So so the question was, did I consider streaming straight from the appliance to say Kinesis or just to Splunk? Yeah. So
and versus consume it in CloudWatch logs.
Yeah. So the key issues there are around the appliance's capabilities. So typically you have something called like a TA, which is a technical assistant in Splunk, which has the ability to go and ask these questions. But this appliance was the kind of dumb, right? They only had syslog and they had manual download in HTTP. There's no stream out. There's nothing. So syslog is their stream. But as I said, I started with because it's in an island on the internet and syslog is very insecure. You're not going to ship that over the internet. And there's no way to get a private network to this appliance in this scenario. So it was a very novel solution. It's unlikely you'd face something like this in the real world, but it does exist.
I've seen it written that you can use an environment variable called TZ for time zone in Lambda and we'll change it, but I've never been able to get it to work.
Right. So apparently there is a TZ environment variable. Yes, it really depends on your libraries. Like each library uses time zone in a completely different way. Some of them rely on the TZ, the time zone files, and some of them will use environment variables. I always find every time I need to math that I need to figure it out again because I always forget. So I'm glad it's not just me that had that issue because yeah, cool.
How long was your CloudWatch logs retention?
I believe it was 30 days by default, but I can't recall. It was several years ago when I did this. It might have been 7 days. It could have been 30.
Okay, so it stayed in 30 days in CloudWatch logs, then you sent Splunk, and then eventually they just.
Yeah, exactly. These all just fall off a cliff after the 30 days, so you're not paying for them beyond that retention window. Yeah. So it was I said this is what it's going to do, and security didn't come back and say do it otherwise. So that's what it was. Could have been retuned. It could have been tuned for cost, or it could have been tuned for retention. Yeah. It could have been shipped off to another source like an S3 bucket. Sorry, I use this and AWS, so sometimes I confuse it. An S3 bucket and versioning or some other non-repudiation could be put on as well. That might be some other things if you really cared about non-repudiation, but they deemed this sufficient for this particular solution.
Thanks, Tom.
That's it, done.
Just a quick